Okay, good evening everyone. Today we are going to discuss about linear algebra and what are its applications in data science. So let me share my screen. Is the screen visible to everyone?
Yes, Ram.
Okay, thank you. Now we have if you have any data, like we will have for example, we have taken a data of 100 students where we have collected m features from those 100 students. We have got a problem we have various features like height, weight, hair color, average weight. These are also called as variables. Now we need to know one feature which will describe the all students. So we need to find that kind of features where they are most important features that best describe a student. So with that single variable or feature, we can describe every student and we can differentiate the in between the students. So that's what that is the example of a problem where if we have got any data set, then we need to select a feature from that for our best feature for our problem solving. So for this purpose, we have dimensionality reduction in linear algebra, where we come across PCA, principal component analysis, and SVD, single value decomposition. Where we will decrease our dimensionality. Nothing but we are going to decrease some of the features or variables. Uh, those are These two are the methods we are going to use in data science for dimensionality reduction. So for example, we can see like principal component analysis. Here, if we have like original data, then what we will do, we will linearly transform them and reduce the data. So that is something like feature extraction. So for this purpose, we use two methods like principal component analysis and dimensional and SVD. So for this, we need to know some of the basic concepts in linear algebra. For using PCA and SVD, we need to know some of the basic things. So what are the basic things means? We need to know what are the vectors, and we need to know what are the matrices, and we need to know what is a linear equation, and we need to know like eigenvalues and eigenvectors. So if we know these basic concepts, then we will be knowing how to use them for uh, dimensionality reduction. Like in PCA, either we can go for principal component analysis or like SVD. So we'll start with vectors. Now, let me share the screen once again. So I'll open vectors. So this is first we need to know whenever we have got any data, either it may be like a scalar or vector quantity. If it has got only like a single variable, then we can represent it by like scalar quantity. Otherwise, if you have like two or more variables, then we will come across this vectors. So it represents a component on x-axis and component on y-axis. Like the basic notation is like capital A or A bar. The basic notation of the vector is either we will represent it bold letters or on top arrow. So that is the basic notation. So these are some of the basic concepts in vectors. like actually A is equal to like if we are taking this, let me draw. Like here I can say A is equal to some vector. I can take it as x comma y. Okay. So here x represents the x component of a vector A. Basically, we represent A bar, and y is the y component of y on y axis. So here either we represent a vector y either in a row or by column, like x and y. So we can represent a vector in two forms. Either it may be in a row or column, like n by 1 or 1 by n matrix we can represent. So that is regarding the vector. Next we have like the basic things we need to know in vectors is like adding of vectors. Now how we can add vectors? Like if you have selected a vector AB and another vector BC, then AC represents the net displacement of these two vectors. Like if you are adding A, B, and BC, we will get AC, and the direction of this represents the same thing. So when adding vectors, their direction must be taken into account. Units must be same. So if this has got some centimeters, then this BC should be in centimeters. So that is regarding the units. And we have like geometric methods and algebraic methods for adding any vectors. Like we can see in this, like if we have a vector and we have another vector b vector, then how we can add this means we represent it by a orange color, like a bar plus b bar. Even if you are like going for the calculating the length of a vector and b vector, if we add those two things, then we will get this length of a vector plus b vector. The same, either the length of a plus b vector will be same as addition of length of a vector plus length of b vector. So here also we have another, we are adding four vectors here. Now how we can get is AB we will get as like AC, a vector plus b vector, and we have like a vector plus b vector plus c vector, and this represents the whole, all the vector summation is a vector plus b vector plus c plus d vector. So when we are adding like four vectors, we'll get this resulting. And we have like a vector and b vector. We can also do in a similar manner. We can form a polygon or parallelogram in this example. It is a parallelogram where like the diagonal represents the resultant, that is a vector plus b vector. So the special case of vector addition, that is a minus b. Add the negative of a subtracted vector, like we can see here. Actual b vector is moving in this direction, but if you are taking it as negative, that is it will rotate like 180 degrees, and the after rotation of b vector 180 degrees, it is called as minus b, and the resultant is a vector minus b vector. So here vectors can be described by their magnitude and direction. For example, your displacement is 1.5 meter at an angle of 25 degrees. So here, like this represents the vector. So here we can also see in another manner, like uh, Ry is 0.634 meter and Rx is 1.36 meter. So we can represent this particular vector like 1.36 uh, in a like in this notation. We can write here 1.36 and 0.634. So the that row or column represents this vector R vector. So the components of a vector are something like, we know, do not need much. I'll move on. This is the more about components is like this represents the length of a vector, and we will get like square root of ax square plus ay square. Then we can get the length of the vector, and tan theta is nothing but here we can get the direction of the vector by this formula, that is tan theta is equal to ay by ax. Next we have like unit vectors where I hat and j hat and k hat will be like uh, unit vector. It represents a unit vector actually. I hat comma j hat comma k hat represents a unit vector in 3 dimensions. If we have any two in two directions like I hat or j hat, then it represents in x and y axis. If it is j and k, then it means that our vector is in plane yz. Here we have like adding of vectors.
Ramu, one addition to the point.
Yeah.
So guys, everybody just understand here one point here. See, we are getting the data points, right? When we start with our data science classes and all, we were reading about the data, how it's represented, how many columns, how much, what kind of data we are getting, and all those things we generally see. So at this point, this whatever the vector, right? Vector is a point like some collection of data points actually. So if particular data is representing one vector or maybe multiple vectors also possible, because you can take some graph or something, and in the graph you just keep the dot 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 dot, right? So when you keep the dot dot dot, what happens, like you can take as many as vectors, right? Let me share my screen actually.
I'm showing this. You can see here in this picture.
You have video or some graph is there?
Yes, yes. I'm okay, okay. I have not shared that PPT. Okay, anyway, I will show the data points where all the vectors we can see.
If you have the data points, can you bring up that one?
Yes, yes. I am opening it. I'm sharing it. Okay.
Yeah.
Uh,
So yeah, you take that variance study about. Yeah, this is general very normal example. Like when you put the whatever the data points you have, you just like this x and corresponding y values are representing like this, right? So for whatever the y x value and this is a y, okay, something you forget about, even you take one column value, one column related, how it is represented in something. So this all these data points are just like scattered. Like if you, even if you think here, right, generally you want to connect from the whatever the lowest data point is somewhere minus 4 comma 4, somewhere it is there, no, minus 4 comma 4. So
Yes, yes.
you can make one vector to again 4 comma 6 very corner, or 2 comma 2 comma minus 2. 2 comma minus 2 is another line you can make. So that whatever the connected points, right, you can make one vector out of it. Whether you consider that one or not is a different thing, but the thing is that even in this also that will show that vector like minus 4 comma 4 to 2 comma 2 comma 2, you can make one vector again. 4 comma 4 also can make, 4 comma 6 also can make. In that process you may connect to so many data points you are connecting. So that becomes a like set of vectors here. When you are taking this, even if you take, if you even if you generally looking at all these data points, some thick line you are making, so which is a more permissible or more good way, or like which can cover most of the data points nearby it, if not exact data points, it will cover the more nearest, like it will cover most of the data points. If you try to plot a line, it will be around minus 4 comma 4 2 or somewhere below that, like that, or minus 4.5 or 4 point somewhere to minus 4.5 comma 4 2, directly in between. If you are making a line, that also vector that covers the most of the data points. So why we need these vector operations? Of course, now currently whatever the algorithms you are going to use in future and all, that is internally these operations are embedded. We explicitly need not do that part. But the thing is that how these data points are connected, how the internally how it is aligned the data points. Based on that, we have to make some um, either prediction or inference or something. Okay, whether it is linear or not linear, whether it is exponentially or linear growth is there or not. Even if you see when the number x is growing, y also growing, right? In this case, when the x value is increasing 4, that y value also somewhere 4. It is linearly growing. It is not bad actually, right? So, but for that purpose, we need to know whether linearly growing or not growing also. You should say sometimes if it is going negative side, like the scattered point is the right word, some angular it is there, no, sometimes the direction may come down, sometimes the direction go back, sometimes it will be completely like scattered across. It may not show any behavior also. So these all these things are possible. We cannot say that all the data will be looking like this only. Data may look like anything, but in this, no, internally at lowest level, these data points are connected in along a line or not a line, but that can be put under some vectors. Those vectors actually lead to any decision making or any operations we are trying to make in future purpose. Okay, I think you people got what I'm saying.
Yes, yes.
Yeah. So okay, Ramu, you go ahead with the next steps of the things in this
Okay.
once vectors. Yeah.
Okay. So till now we have discussed regarding the vectors. So next we will go with the matrix operations. Why we need this means we need to know actually for finding eigenvalues and eigenvectors. We need to know what is a vector and what are the matrices. Then only we can know how to find our what are eigenvalues and what are eigenvectors. So for knowing covariance and variance, which are used in like in PCA, principal component analysis, we go for like variance covariance matrices. So there will for finding out variance or covariance matrices, we need to know what are actually eigenvalues and eigenvectors. So for that purpose, we are studying. Actually, we are starting with vectors because these are the basic things. Then we need to move. Then we can move on to the like matrices. Then eigenvalues and eigenvectors. Then variance and covariance matrix and linear equations. Actually, we know everybody knows what are linear equations. Then how these by knowing these concepts, how we can implement PCA in any given data set, like PCR, SPDM data set. If you know only like what is a vector and what are the vector operations and matrix operations, eigenvalues and eigenvectors and covariance matrix. If you know these things, then we can go for PCA method on a data set. Next, we will move on to the matrix. Let me share the screen. Now everybody able to see this learning objectives, right, of matrices. Are you able to see this learning objectives?
Yes, Ram.
Okay, okay. Uh, for cost estimation or sale projection and factory problems can be solved by using matrices. Now, and expressing in vector form. The same thing till now, Sri Krishna said the same thing. What are the main actually why we need to learning objectives? He explained before, and expressing day-to-day life problems in matrix form, and matrix notation and operations are used in electronic spreadsheet, advanced statistics, expressing simultaneous linear equations in matrix form. Here comes whenever we are representing in matrix forms, then we need linear equations. So that's how this linear algebra comes into play. Whenever we are representing any data set like m by n order, here I will show you what is m by n. So here you can see these are the types of matrices. Here it is 0, 0 and 0, 0. This is one of the matrix, that is 0 matrix. And the order of this matrix is 2 by 2. And here we can see 2 rows and 3 columns. And the order of this is something like 2 by 3. So if the order goes on increases, like m by n is something like 21 by some 50 or 1000, then there we need to go for the help of computer for solving n number of linear equations. So that's how for 2 by 2 and 2 by 3 or 3 by 2 and 2 by up to 4th order, we can go with manual operations. But more than 4th order, we need to take the help of computer for solving these matrices. So why we need to solve these or linear equations means here each column represents a feature or variable, and each row represents different features, and each column represents like a different variables. So that's how we can we are discussing here something expressing day-to-day life problems in a matrix form, and we can go for solving that problems. So that is the main objective of learning these matrices, and where we use for our data science. So a matrix is an ordered rectangular array of numbers that represent some data. I said you what is order, like 2 by 2 or 3 by 2, 3 by 3 or 2 by 3, anything. If 2 by 2 is the order of the matrix, then we can say it is second order. If 3 by 3, then we can call it as third order matrix. 4 by 4, we can call it as fourth order matrix. N by n, we can call it as nth order matrix. M by m, we can call it as m order matrix. Now, a matrix on its own has no value. It is just a representation of data. Actually, so what is matrix means? It is only a representation of data. And whenever we are coming across this data, actually the linear algebra is something like the mathematics of data. Whenever we are talking about linear algebra means we have like 1, 2, 3, 4. These are the numbers, like real numbers, 0 to infinite. So real numbers, we are doing some addition, subtraction, and some division or some percentages, something. If you are doing something, we are calling it as mathematics. But in data, if you are doing anything, that is linear algebra. Linear algebra is the basic mathematics of the data. So here, this comes in the linear algebra, we have like vector matrices. So whenever we are calling this matrix, it is nothing but actually it has no value on its own, but it is a general representation of data, and it could be like data associated with manufactured quantity in a factory, speed of a rocket, etc. Forms the basis of computer programming. A matrix is used in solving equations that represent in business problems. So we will see an example. will like everybody knows this is a row matrix and this is a column matrix and these are the zero matrix, and this is nothing but if the columns and rows are equal, then we call it a square matrix. Uh, Diagonal matrix is nothing but where other than the non-diagonal elements are zeros and only diagonal elements are greater than zero. So what is like scalar matrix? A square matrix is called a squarer matrix if diagonal elements are same and other are zero, like Aij, Aii, uh, and Ajj are equal, then we call it as scalar matrix. What is identity matrix means? Only the diagonal elements are one and other than non-diagonal elements are zero. The basic representation of any element in a matrix is Aij, where I represents row and J represents column. If you are talking about A, 2, 3, then it represents like a element in the second row and third column. That is a representation of that element like A, 2, 3. The basic operations in matrices are nothing but addition. We'll do the normal addition like 2 plus 40 and 45 plus 7, nothing but this is a normal addition. And like addition is commutative, and we can do like A plus B is equal to B plus A. But in multiplication, it might not be the same, like AB will not be equal to BA. So these are some of the things we need to know in like multiplication of a matrix by a scalar. So this is also normal multiplication. Scalar multiplication of matrix is nothing but normal multiplication what we do to the numbers. But we need to multiply the single k is nothing but here scalar and it is given as 2. So we need to multiply it with each element in the matrix. Now, when it comes to multiplication of matrices, we need to follow some of the rules. Like here we can see 1 by 2, 1, 2, 3, 4, and minus 1, 2, 0, 1, 2, 1. We have like 2 by 2 and 3 by 2 matrix where multiplication is not possible. Because when we are doing multiplication operation, we do like this. We'll select one first row and we multiply with the first column. So in this first row, we have only 2 elements. But if you are selecting the first column, we have like 3 elements. So basically, the multiplication is not possible between these two matrices. So it is only possible when the like rows in the first matrix should be equal to the here like here multiplication is possible. Like order of new matrix is m by n and np, then ab is mp. So here is nothing but next we will come to know. You can see here we have like 3 columns in this matrix and 3 rows in this. Then only the matrix multiplication is possible. Otherwise, we can see in this previous example, like here 2 and 3, it is not possible. But here 3 and 3, if these two are equal, then it is possible. Right? If we have 3 columns in the first matrix and 3 rows in the second matrix, then only matrix multiplication is possible. And how we will do means nothing but we will select the first row and the first column, like 2 into 4, the first element. Like we will from this we will get 4 elements, and like the order of this after multiplication would be like 2 by 2. We can see 2 by 3 and 3 by 2 matrix here. So after multiplying, as we have discussed here, like m by n and n by p, we will get m by p order. So similarly, if you are multiplying 2 by 3 and 3 by 2, we will get 2 by 2 matrix actually. So that is nothing but here we can see like how we are doing multiplication means nothing but the first element and the first element in the first row of first matrix and first element in first column of the second matrix are multiplied and they are added to the next term, that is 3 into 1 and 1 into 5. So this is a basic mathematics. Uh, this is the matrix multiplication we need to know. This is also nothing but the same thing, procedure for multiplication. We can refer for this. So what is the transpose of matrix is nothing but here we are going to interchange the column to rows and rows to column. Then we call it as transpose of a matrix. Now you can see in this example, if A is equal to something 3 minus 1 0 4 2 1, then A transpose is nothing but 3 minus 1 0 and 4 2 1. So this is the transpose of any matrix. So matrix formed by interchanging rows and columns of A is called as transpose. Now what is symmetric matrix means? A square matrix A is called symmetric if A transpose is equal to A, then we call it as a symmetric matrix. Here we can see the example 1 minus 1 minus 1 3. If we interchange the rows to columns or columns to rows, then the matrix will be same. So that's why it is called as symmetric matrix. Here also, this is also one of the example, like if you are interchanging this column to row, then also the elements are same 1 2 3 and 1 2 3. And in the 2 minus 1 5, 2 minus 1 5. So these kind of matrices are called as symmetric matrices. And skew symmetry is nothing but where like a square matrix A is called skew symmetry